We'll proceed in vector summation and integral calculus. Vector summation and integral calculus, we have waged a war against the vector summation and integral calculus. Okay, what it is, vector summation and integral calculus, what it is. Okay, concept is, can we divide our problem into n different parts and solve part by part and then we sum it. While solving a single part, if I divide my problem into n different parts, while solving a particular part, then can we use vector out there? Otherwise, we will solve the problem into divide the problem into part by part and then solve part by part and then we sum it. When we sum n component, when we have divided the problem into n different parts, and then we sum the n components, and then while summing it, if we believe that this n component summation would not be perfect, then we go for integral calculus. Mind blowing, we are trying to calculate a summation that is compound interest. And compound interest, if someone has deposited money in the account and compound interest is coming continuous manner. If there is a fixed deposit in the account in the bank, if there is a fixed deposit in the bank, typically bank give compound interest every year. Every year interest will be compounded, principal amount and interest amount. They will club together after 1 year and that will become principal amount. If C is the interest rate every year, if C is the interest rate every year, then at the end of 1 year, if Y0, 0 means time, when time equal to 0, Y money has been deposited in the account, fixed deposit. Y0 money at the end of 1 year at the rate of C%, that at the end of 1 year, Y0 at the end of 1 year, Y0 would become Y0 and in bracket 1 plus C. Y0 in bracket 1 plus C. Okay, means if I say, understandable, right? If there is there is an amount and it is compounding every year at the rate of C% per year, then Y0 amount will become Y0 plus Y0 into C at the end of 1 year. Y0 in bracket 1 plus C. At the end of T year, Y0 1 plus C to the power T. Okay. If I say 1 plus C is A, any constant A, then Y0 into A to the power T. Make sense? Okay, this is called annual compounding. If I talk about monthly compounding, day-wise compounding, per second compounding, continuous compounding. Continuous compounding may be per day compounding. Per day compounding means if C is the interest rate per year, then per day interest rate will be C by 365 or 366. 365 will be the new interest rate per day, and every day interest will be calculated and then principal and interest will get added and new principal will become principal plus interest, and for the next day new calculation will happen with the interest rate C by 365. Okay, in that fashion, the equation will turn into y0 plus 1 plus c. C will become c by 365 every day if it is happening. C by 365 to the power 365 for 1 year into t for t years. If I divide 1 year into n different parts, n different periods, okay, means compound interest period is divided by n. What I'm trying to say, if compound interest period is 1 year and if I divide it by n and n is 365, then compound interest is happening every day. In that fashion, the equation is y0, that is the beginning amount someone has deposited in the fixed deposit, multiplied by 1 plus c, c by n, because interest will happen per day, then it will be c by n, bracket close to the power n, because to reach 1 year it will be to the power n, 1 plus c, 1 plus c, 1 plus c. If I keep on multiplying, for each period we are multiplying, one period is for 1 day, So to the power n, because 1 year I have divided into n different parts, where n is 365 if I'm saying per day. It is 12 if I'm saying it is per month. Okay, so it is y0 in bracket 1 plus c by n to the power n. After t number of years, n into t. Okay, that is the case. Then we saw that 1 plus c by n to the power n, where n tends to infinity, that will be e to the power c. This is what our previous video, how it becomes. 1 plus c by n, bracket close to the power n, where n tends to infinity, it will be e to the power c. So it becomes y0 e to the power c into t if it is continuous compounding. Continuous compounding means per day it may compound. Someone would say per second also. Doesn't matter. More n is more it will be towards e to the power c. So it is y0 e to the power ct. If someone is depositing S amount of money, or well-wisher or whoever, in the account every year, consider someone is depositing money in the account S amount of money every year, or someone is withdrawing S amount every year. Both is true. Let's go for better thing. So someone is depositing S amount every year. Then first amount, if this is the span of 1 year, if this is the span of 1 year, then this is Y0 got deposited. And at the end of 1 year, extra S amount got deposited in the fixed deposit. So at the end of 1 year, we have Y0 into e to the power C plus S. At the end of 2 years, we have y0 into e to the power c into e to the power c plus s into e to the power c plus s someone has deposited. Means at the end of 2 years, 2s has been deposited, but first s got chance to interest, get the interest only for 1 year, whereas the beginning money got 2 year chance to get the interest. So at the end of T year, the amount, that is Y in the fixed deposit, is Y0, that is first amount, at the zeroth time, Y0 e to the power Ct, where T is number of years, plus S, that is the first S e to the power C, T minus 1. Next S into e to the power C, T minus 2. Last S is e to the power C, T minus T, 0, 1. Okay, now question arises that first is alright, y0 into e to the power ct is alright. What about next one? Next one is plus s, and in bracket e to the power c t minus 1 plus e to the power c t minus 2 plus e to the power c t minus 3 plus e to the power 0. What is this? This is the question. Can someone find e to the power c t minus 1 plus e to the power c t minus 2 plus e to the power c t minus 3 plus e to the power 0? Then there are two method to it. Okay, one method we have already discussed, called repeated addition. Repeated addition means let's divide this problem into n different parts. Let's divide this problem into n different parts. Then each one part is e to the power c in bracket t minus 1. One part is e to the power c in bracket t minus 2. Next is e to the power c in bracket t minus 3. Like that. Let's make all parts same. Then how it's possible? It's possible. E to the power c t minus x. Then all are t minus x. Last one is also e to the power c t minus x. All are. Now it is a repeated summation. We have t terms. I have divided my problem into t parts, n part, t parts. Each part is e to the power c t minus x. Each one is e to the power c t minus x, where x is variable. Okay, in that fashion, if we will compute, if we see part by, so we computed part by part. Each part was different earlier, e to the power c t minus 1, e to the power c t minus 2, e to the power c t minus t. Now, when I started tackling part by part, then I saw each part can be made similar, same, e to the power c t minus x. Now all part are e to the power c. We finished it. What have you solved each part? Yeah, we solved each part. How much it is? E to the power c t minus x. Each part, each part. Then let's add it. Now it's simple, right? E to the power ct minus x. If I add for x term, then it will be e to the power ct minus x into x. Okay, then if I watch, if people are watching clearly, x is variable here. And if I have first term that is function over x e to the power c and t minus x, and next term is the independent variable that is x, it is fit case to become integral calculus e to the power c t minus x into dx, where x will go 0 to t. Makes sense? Someone would say not 0 to t, 1 to t. In repeated summation, it will go 0 to t. Like if I have 5 plus 5 three times, then it is 5 into x, where x is 3. 5 plus 5 plus 5 is 5 into 3. Repeated summation of 5. 5 into 3. That is same as 5 into x, where x is 3. Then it is same as 5 into dx, where x dx in limit is 0 to 3, not 1 to 3. It should be 1 to 3, 1 to 3, 1 to 3, but it will go 0 to 3. Similarly, if I have t number of terms to add, then it will go 0 to t. E to the power c and in bracket t minus x dx 0 to t. If someone solve it, then we got it 1 by c and in bracket e to the power ct come down minus 1. 1 by c and in bracket e to the power c t come down minus 1. Someone can try. E to the power c t, e to the power c and in bracket t minus x integration will be minus outside, and then 1 by c minus 1 by c e to the power c in bracket t minus x. That will be the integration. So putting x is 0 to t. First t will make it e to the power 0, that is 1, and next will make e to the power ct. Minus is outside, then it will become kept then 1 by c in bracket e to the power ct come down minus 1. Okay, this is what is available in the book. Is it the correct solution? That is under question mark. Is it the correct solution? If I put t equal to 0, if I put t equal to 0, then e to the power ct, e to the power 0, 1, 1 minus 1, 0. So s has, if I complete it the way we did the integration, if I complete the compound interest y equal to y0 e to the power ct plus s into 1 by c in bracket e to the power ct come down minus 1. S by c in bracket e to the power ct come down minus 1. If t is 0, then s term will become 0. That is alright, because when t is 0 and this side y0 e to the power ct, only y0 means when time is 0, when time is 0, then at that time if the money in the fixed deposit is y0 only, no interest has been computed. When time is 1, then first value y0 into e to the power c, so it will get interest. What about this side? S by c e to the power c, e to the power c minus 1, e to the power c minus 1 by c. S into e to the power c come down minus 1 by c. If this is non-zero, it should be, I'm sorry, this should come as 1, because at the end of 1 year, s factor is s only. At the end of 1 year, how much money is there in the account? That is y0 e to the power c plus s. But s term is s into 1 by c, and in bracket e to the power ct come down minus 1. If I place t equal to 1, okay, if I place t equal to 1, it will become s into 1 by c e to the power c minus 1 by place e to the power c come down minus 1 by c. This term should be 1. If it is not 1, then there is error. There is error. And this is what is written in every book. Certainly there is error, right? Anyway, now we will use different parts. This is called repeated summation. Divide problem into n different parts and make each part look same. You need to push some independent variable out there. Then each part should look exactly same. And then if each part look exactly same, then you can sum it. And while summing it, you can have fx into x, and x is limit 0 to how many times you are summing it. This is called repeated summation integral calculus. Next is successive approximation. Both are our ways. There nothing is mentioned in the book. So successive approximation is if I have summation, if I have summation. So first I divide problem into n different parts. Make every part look similar. You may need to, someone may need to push some independent variable out there. Then everyone will look similar. Once they look similar, it will come in some function. Once it comes in some function, then it can be solved through repeated addition. What is example? Consider example like x square. X square means I have a repeated summation of 1 by 10 whole square plus 1 by 20 whole square plus, I'm sorry, 1 by 10 whole square plus 2 by 10 full whole square plus 3 by 10 full whole square. Hope, I'm sorry. So I'll do it again. It is 1 square by 10, 1 square by 10 plus 2 square by 10 plus 3 square by 10. I believe it is alright. What I'm trying to do so. We'll try again. What I'm trying to do so is consider this is x axis and this is 0 and this is 1. This is 0 and this is 1. Okay, in that fashion, let's chop it into 10 parts. Then this point is 1 by 10. This point is 2 by 10. This point is 3 by 10. This point is 4 by 10. This point is 10 by 10. Okay, it is alright, I believe so. Okay, if it is very difficult to understand, let's take a simple case as I have a section of 1, 1. This section, consider this is x-axis and this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Makes sense? And then we have a function. What is the function? Function is another line. I have a function and function is another line. What is the function? Function is like this. This line is what I'm trying to say that if I have x equal to 1, then I have a height. If I have x equal to 2, then I have a height. When I have x equal to 3, then I have a height. What is this height? This height is 3 square. This height is 2 square. This height is 1 square. What are you trying to solve now? I'm trying to solve what is 1 square plus 2 square plus 3 square plus 4 square up to t terms. T square. Makes sense? 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus t square. How much it will be? Okay, then someone would say, then it is difficult to solve. Go. 1 square plus 2 square plus 3 square plus 4 square up to t square. Okay, if that is the case, then better, can we write it as x square? The problem is 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus t square. That need to be solved. Okay, now or n square plus n square. How to solve it? Let's chop it into n different parts. Then first part is 1 square, another part is 2 square, third part is 3 square, fourth part is 4 square, t square. All are different. Now if I try to solve part by part, then it is impossible. If t is 10,000, then who will solve this much? So when we are solving part by part, if I divide into n different parts, all parts are different. Can I make all parts look same? Yeah, we can make all parts look same. If each part is x, I mean first is x square, second is x square, third is x square, last one is again x square. All are same. Yeah, now we can go for repeated summation. Repeated summation means I have x square plus x square plus x square plus x square plus x square again. These are up to t terms, t number of terms. How much it will be? Then it will be x square into x for x term. X square into x for x term. This is function over x into x. Then it will be fx dx where x is 0 to t. Okay, if I say 5 plus 5 plus 5, 5 plus 5 plus 5 as 5 into 3, 5 into x, 5 dx, where x is 0 to 3. Similarly, I have x square plus x square plus x square plus x square. So many terms. If I say for x term, then x square into x square dx, and then x goes from 0 to t. X square is x to the power 3 by 3, 0 to 2. T to the power 3 by 3 will be net addition. Someone will say it may not be perfect. Okay, it is t to the power 3 by 3. You are saying it may not be perfect. Let's try. Let's take t as 5. Let's take t as 5. Then how much it will be? Or let's take t as 4. Then 1 square plus 2 square plus 3 square plus 4 square. 4 square is 40. 3 square is 4 square is 16. 3 square is 9. That will come as 25. 2 square is 4, that will come as 29, and 130. If I had taken up to 5, then 30 plus 25, 55. It will come as 55. Okay, with our formula, it is t to the power 3 by 3. T is 5. 5 to the power 3. 5 to the power 3 will come as 125. 125 by 3. Then how much it will come? 5 by 3, how much it will come? 125 by 3. That will come around, I believe, it will come around 42. But we had 55. Difference is there. 42. Okay, difference is there. If I take 1 down also, then it is 20, 30. I remember. If I take up to 4 also, then it is 30. Then it is 140. So difference is there. This may not be a perfect solution. I don't know how what is actually the perfect solution. Probably it will be 5 into 6 into 7 or something like that by 3. 5 is, or if I calculate up to 4, then 4 into 5 into 6, how much it will come? 4 into 5 will be 20. 20 into 6 will be 120. 120, 120 by 3, it will come as 40. I don't know what is actual solution is. That is 1 square plus 2 square plus 3 square plus 4 square up to t term. But this is what we are getting through repeated summation, and that is x to the power 3 by 3. Okay, for simple case, if I take x equal to x, 1 plus 2 plus 3 plus 4 plus 5 plus up to t, then it will come as x dx. It will come as x dx. X dx will be x square by 2. The solution is x square by 2. X square by 2 is not the actual solution. Solution is x into x plus 1 by 2. That I know. If someone is trying to add 1 plus 2 plus 3 plus 4 up to x term, then it will be x into x plus 1 by 2. If I go with repeated addition, it will come as x into x by 2. Okay, it is near to the solution, but it is not perfect solution. But this is what we get through repeated summation. If someone is doing 1 square plus 2 square plus 3 square plus 4 square, then it will come as x to the power 3 by 3. I don't know what is the actual solution. Okay, there is another way. This is called repeated. Whatever the problem is, divide into n different parts. Each part make they look similar. If it is 1 plus 2 plus 3 plus 4 is there, now everyone will look similar. If I say x plus x plus x plus x plus x, okay, everything will look similar. If I say x plus x plus x plus x, then x plus x x time will be x into x dx, x square by 2. Or if it is x square x square x square, then x square dx, x to the power 3 by 3. Okay, it will be near to the solution. This is the one way of solving it. Another way of solving it is through successive approximation. Successive approximation says what we want. We want successive approximation. Say that this is the equation. This is the equation. Okay, we are taking long time with this because this is a very big invention. We will say very big finding to Find anything. Anything. Like if I say successive approximation, consider there is a flat line. There is a flat line like this, and it is x. If this is x axis, this is x. At x equal to x, then height is x only. 2, then height is 2. 3, height is 3. X is height is x. Okay, now I am trying to calculate all x at x equal to 1, 2, 3, 4, all the heights we are trying to add. If I'm trying to add all the height, okay, then concept is rather than adding it 1 plus 2 plus 3 plus 4 plus 5, that is same as summation I equal to 1 to n I. But what is that? No one knows. If I say summation sigma sine summation x equal to 1 to n x or fx, fx is x. This is what we are doing. But what it is, no one knows. Can we use integral calculus? If I use integral calculus means I have to bring I have to bring one curve. I have to bring one function. If this is if this is fx, what is fx? Fx equal to 1. Sorry, fx equal to x. Function over x is x. Whatever you take on x-axis and x, height will be x only, same thing. So this line equation is fx equal to x. Now I am chopping it at x equal to 1, 2, 3, 4 and tell me all the summation of all the heights. Only the heights. Okay, but height they follow. If I make a line connecting all the tip of all the heights, then it will be a straight line. If I construct a line connecting tip of all the height, it will be a straight line, and that is fx, that is x. But we want 1 plus 2 plus 3 plus 4 plus 5. If I try to do with integral calculus, and if I take any fx and I do the integration of fx from 0 to t or 0 to n fx dx, it will calculate the underneath area. This is the problem of integration. Whatever function someone takes, and if he does the integration, he will finally land up in calculating the underneath area. This underneath area should be same as if I add all the vertical. For 100% it will not be the same. Adding vertical is different than calculating the area. Okay, if I have chopped into t part, if I have 0 to x, 0 to x, I have chopped into x part. Let us start from x equal to 1, 2, 3, 4. I'm adding all the vertical. Makes sense? I'm adding all the vertical. If I do fx dx, then I'm adding all the sub area, because this will give underneath area. Underneath area is same as addition of all sub area. If I take x equal to 1, then this is fx. Fx into this area. Fx into this area. Fx into this area. Into this width. Someone would say it looks similar. Fx into this width looks similar because width is 1 1 whatsoever. We will see that it may, I believe we have already seen. There can be another scenario where I take as 0. Okay, there can be another scenario. What is the scenario? Another scenario. Another scenario can be now I have 0 to x. I chop it into x different parts. What about if I chop into 2x parts? Into 2 into x part. If I have it is 10, then it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 part I have chopped it. And then I'm trying to calculate 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, 10. Consider I chop it into 20 parts. If I chop it into 20 parts, it will become like 1 plus 1.5 plus 2 plus 2.5 plus 3 plus 3.5 plus, because 20 terms will come up to 10. Then that summation, but if I try to calculate fx dx, where fx is x, fx dx between 0 to 10 will always be same. It will never vary. But if I chop 10 times, 20 times, 30 times, addition of all the height will start changing. So both are not same. Addition of all the heights is not same as underneath area, because I can chop in many parts. 0 to 10 I can chop in 10 parts. 0 to 10 I can chop in 20 parts, 30 parts, 100 parts. In that fashion, addition of all vertical will grow if I chop in more parts, but area will be same. If I chop this 0 to 10 into 100 sections, and if I calculate area of each section, and if I add it, then it will be same as if I chop it into 10 sections and calculate the area of each subsection. No difference. Fx ds will always be same. The question is arriving, but both okay. What is fx? Fx equal to x. What is fx? Fx is x. It will go like a slant line. Fx equal to x. If fx is equal to x, then consider I am chopping it into 20 parts. Consider I am chopping it into 20 parts. Make sense? 0 to 10, I am chopping it into 20 parts. Okay, it starts with x equal to 1. Then it will go up to 10. 20 part I have chopped it. What you want? I want at 1, since it is following equation of fx equal to x, at x equal to 1 height will be 1, at x equal to 1.5 height will be 1.5, like that. So fundamental is what is 1 plus 3 by 2 plus 2 plus 5 by 2 plus 3 plus 7 by 2, or 1 plus 1 into 1 1 1 by 2 plus 2 plus 2 1 by 2 2 2 and a half plus 3 and a half plus 4 4 and a half up to 10. How much it will be? But it is following equation of fx equal to x. That is true. Okay, how I can find it through integral calculus? Integral calculus means if I have fx equal to x and it is x is 1 to 10, fx dx, if I do, it will give the area. But that area may not be same as what we are doing, because I can chop in 30 part also, 100 part also. Okay, in that fashion, if I try to calculate through integral calculus, then the equation through which we try to calculate the area, the equation will start varying. If I have chopped fx into 10 different parts and then I'm trying to calculate through integral calculus, consider I have a function called gx. Gx is another function at all, and that function, if I calculate the area underneath from x equal to 0 to 10, that area will be same as 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Same. But if I have another thing, that is 1 plus 1.5 plus 2 plus 2.5, 20 times. If I go from 0 to 10, 20 times. Okay, then gx will change now. Because now the addition is around, I believe, double. If someone is dividing into 10 part, whatever addition he is saying, when he is dividing into 20 part, addition will double. If I try to calculate through integral calculus, I have any function called gx, then gx will again change. Now looking at number of section I am making, gx dx, I am trying to achieve in sigma sign I equal to 1 to n, where n is number of parts we have made. I equal to 1 to n, fx. Okay, what is fx? Okay, I can say fx is kind of fx is how much it is. Fx is x. Fx is x, and I is going 1 to n every 0.5. Okay, or I can say I can change the fx whatsoever it is. What is fx? Whatever. Fx, consider fx is x only, and we have done kind of 20 parts. Now can fx summation of fx 20 times, how I can bring it to integral calculus, that is called gx dx, integration from 0 to 10. Dx will keep changing if I make more cut in the fx. If I make more and more cut in the fx, dx will keep changing. Makes sense? So that it will compensate the change here, and new gx keep on coming, and then if I integrate, limit is same, 0 to 10. Dx will keep changing if I make different chop, because if I make different chop between 0 to 10, it will net addition will vary. Okay, successive, if I say repeated summation, the way we started with the repeated summation, what if I see, then it is 1 plus 1.5x plus, sorry, x, it is x only. Repeated summation means x only. How much it will be? If I say 1 plus 1 and a half plus 2 plus 2 and a half plus 3 and a half, like that up to 10. If I say, then equation is x only. But x is how much it is? X plus x plus x plus x 20 times, or x into x, x dx, x dx, where x is going 0 to 20. No. X into 0 to 20. 0 to 20, if I say, then it will be 1 plus 2 plus 3 plus 4 plus 5. It is not like that. It is different. It is 3 by 2x. Someone can try. Okay. Fx will be little different. Okay. Someone can try. Okay. Anyway, right now the way we have started discussion with the successive, someone can try. How I can, there are two ways we are trying to find the addition to solve it through integral calculus. One way is repeated summation. You divide the problem into n different parts, and make every part look similar. Make every part look similar. Okay, how much it will be? If I say it is 1 and then 1.5 and then it is something like that. If I double it, consider if I double it, then it will become 1, 3, 1, 1.5. First will be 1. If I double it, the first will be 2, second will be 3, third will be 2, it will become 4, then it will become 5, it will become 6, and then it will become 10. So it is looking like 2x. The formula is 2x, where x is going from 1 to 10. I believe it is all right. No, it is all right. It is 2x, where 2x, 2x means if x is 1, if x is 1, then it is 2. When x is 2, x is 2, then it is 3. Okay, 2x by 2. It is x only, 2x. But it will go, x will go 1, 2, 3, 4, 5, 6, whatsoever. Whatever it comes, then we have to divide it by 2. I think so. Okay, first is 1, then 1.5, then 2, then 2.5. I have to add till 10. 20 factors are there. If I say my algebraic equation, how I can settle every part in same formula, then it will be 2x, where x will vary from 1, 2, 3, 4, 5, 6, 7, 8. Okay, something like that. Or if it is x, then it will be, if it is x, then how much it will be? If it is x, then it is something like 0 to 10. I have chopped it into 20 parts. Okay, then it will be each portion. If I chop 0 to 1, if I chop 0 to 1 into 20 parts, 20 parts, then it will be x by 20, where x will move like this 1, 2, 3, 4, 5, 6. Makes sense? If I chop 0 to 10 into 20 parts, then each part will be 1 by 20, 2 by 20, 3 by 20, 4 by 20, where x will go 1, 2, 3, 4, 5, 6, 7, 8, like that. So I can say x by 10 is the formula, where x is going 1, 2, 3, 4. This is what we are trying to add. Okay, similar way, if I divide whatever we are doing, x by, okay, we are dividing. Consider if I divide 0 to 1 into 20 parts, then it is x by 20, x by 20, x by 20. Okay, then if I multiply by 10, if I multiply by 10, how much it will be? Someone can try. Okay, if I say, up, 1 plus x by 2, x plus 1 by 2, I think so. If I x is 1, x is, someone can try what the formula will come. And that I have to keep adding. This is really complex. Anyway, if I go through repeated addition, if I go through repeated addition, where the function is, hope it is very complex. It is very, let's go for simple one. Let's go for the function is, consider a function is x only, where x is going, or if I hope too much confusion is there. Okay, if I take function as x, how much the addition will be if I say 1 plus 1.5 plus 2 plus 2.5 or something like that, then how much it will come? Hope too much confusion. Anyway, let's do with the simple one. We will try again. So we let's through successive integration we are talking. Let's take that we are trying to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, something like that. Okay, something like that. If we try in that fashion, okay, or let's take we have 0 to 10. I'm sorry, we have 0 to 1. We did in previous session also. We have 0 and we have 1. Okay, let's chop into 10 different parts. If I chop into 10 different parts, okay, then we have now here we have it is 1 by 10, 2 by 10, 3 by 10 like that. Function is x only. So height will be 1 by 10 plus 2 by 10 plus 3 by 10 plus 4 by 10 plus 5 by 10 like that. I have chopped 0. I have chopped 0 to 1. I have chopped 0 to 1 into 10 different parts. 0 to 1 into 10 different parts. If I take the x on x-axis, this is 1 by 10, this is 2 by 10, this is 3 by 10, this is 10 by 10. I have a slant line equation and where height is a slant line and its equation is x. X means if it is 1 by 10 then height is 1 by 10. If it is 2 by 10 then height is 2 by 10. If it is 3 by 10 then height is 3 by 10. What it will be? Now the question is how much it will be 1 by 10 plus 2 by 10 plus 3 by 10 plus 4 by 10 like this up to 10 by 10. Okay, if I take it as a kind, let's forget the repeated addition. Let's go through the successive approximation in integral calculus. What you want? The question is what is 1 by 10 plus 2 by 10 plus 3 by 10 plus 4 by 10 plus 10 by 10. Then someone is very clever. He will see that along x-axis 0 to 1 is, is 0 to 1 is divided into 10 different parts. It starts with 1 by 10, 2 by 10, 3 by 10 like that. And there is a, if this is x-axis, then there is a line, slant line, and equation is x. Equation is x. Okay, okay, if I write in a sigma manner, if I write in a summation manner, it will be summation of x equal to 1, it is summation of I equal to 1 to 10 fx, where fx is I by 10. Makes sense? Okay, or someone can say sigma sine x equal to 1 to 10. Sigma sine x equal to 1 to 10. Summation of fx where x is 1 to 10. What is fx? Fx is x by 10. The fx is x by 10. Means if x is going 1 to 10, then it will be 1 by 10 plus 2 by 10. Now it is clear. Okay, consider I am trying to add number 1 by 10 plus 2 by 10 up to 10 by 10. Then I can reframe it as there is a function called x by, there is a function, actually there is a function called x. There is a function called x and this is x-axis. Along x-axis, we have done a we have cut it down in 10 parts and each part is 1 by 10, 2 by 10 like that. So if this function is x, then height will be x only. So at each x, height will be like that. When x is 1 by 10, 2 by 10, 3 by 10, height will be like that. How to add it? Okay, whatsoever. Now if I see it is, okay, what is your function? Now somebody is asking, what is your fx? Fx is x. Fx is x, where it is chopped at x equal to 1 by 10, 2 by 10, 3 by 10, 4 by 10, something like that. Okay, what you're trying, okay, we have demonstrated in the past video. Okay, so consider this is x-axis. Along x-axis, I have chopped at 1 by 10, 2 by 10, 3 by 10, 4 by 10 like that. Consider this is any x. If this is x, then what is the height at this point? This x may be 3 by 10. If this is, it may be 3 by 10. If this is 3 by 10, then what is height here? The height is again x only, any x. If I take any x, it is 0 and it is 1. If it is 0, it is 1. I have chopped it into 10 different parts. First is 1 by 10, 2 by 10, 3 by 10, 4 by 10. Like that, it is 10 by 10. If I take any point here as x, then what is height here? Same x. The formula is x only. If this x happen to be 5 by 10, then height is 5 by 10. I am trying to add all the 10 heights. Okay, one height is 1 by 10, 2 by 10, 3 by 10, 4 by 10, 10 by 10. At any x, what is the height? X only. At any x, what is the height that is? Then it is x only. Okay, I am trying to add all the x, where x will go from 1 by 10 to 10 by 10. But at any x, height is x only. If I am trying to achieve this through integral calculus, then I will have different functions. This is fx, where function is x, fx equal to x, and it is chopped at 10, 10x, where x are 1 by 10, 2 by 10, 3 by 10. Consider that there is another function called gx, another function called gx, and gx, dx at any x for fx height is x. If I try to calculate same addition through integral calculus, then gx dx, if I say gx dx, if I say gx dx, then this is gx dx that will come as area underneath it, that is from 0 to 1. If this is gx, then gx dx will be area underneath it, dx dx. That area underneath it should be same as what we add 10 times, because I want repeated summation of 1 plus 10, 1 by 10 plus 2 by 10 plus 3 by 10 plus 4 by 10 into 10 by 10 through integral calculus gx dx, x is 0 to 1. In that fashion, if I say, then this function is called x, fx equal to x, that is chopped at different x location. If I go through integral calculus, and that equivalent is gx dx, one is fx that is added 10 times, and one is gx dx. Gx dx means it will give area underneath it. This area should be same as, this full area should be same as summation of all the vertical. If I take any vertical at x, then vertical height is x1. This vertical height x should be same as, if I chop this gx, if I chop this gx area in 10 times, then the x, this is x, the next is x plus 1 by 10. If this is x, then next is x plus 1 by 10. If it is x plus 1 by 10, then this is the sub area. If I add all this sub area, then it will give gx dx. Means what I am trying to say, fx summation x equal to 1 to 10 or whatsoever, summation of fx 10 times, summation of fx 10 times, that it should be same as integration of gx dx from x is 0 to 1. Okay, what is fx? What is fx that it should be equal to? What is fx that it should be equal to? If I say like this, then we take at any point x on x-axis. It is very, very minute, and we have invented it, this philosophy. Can we make any summation through integral calculus? If someone cracks it, then all possible summation anyone is seeing, extremely tedious, impossible to solve through geometric way, he can quickly find through integral way, quickly. Okay, how quickly it is? Now consider, this is x-axis and this is point x. At x, height is x only. This x can be 5 by 10. At 5 by 10, height is 5 by 10. So height is x only. What is sub area here? If I talk in gx dx, what is sub area here? Sub area is between x and x plus 1 by 10. This is the sub area. This sub area should be equal to this height, so that all the height, if I add, that should be equal to all the summation of all the sub area, then both will be same. Means summation of fx equal to integration of gx dx should be same. This is what I am trying to say. Let's take at any point x. If it is any point x, then fx is x. Now it will be clear how I can take fx. Consider fx is x. If fx is x, then what will be gx? So that gx dx 0 to 1 will be both will be same. Oh, I'm sorry. What will be gx? If fx is x, then gx dx from x to x plus 1 by 10 will be same. Sub-area of this sub-area should be exactly same of gx. Gx sub-area should be exactly same as fx, one height. There are 10 heights, there are 10 sub-area. One sub-area we will take, one height we will take. At any x height is x in the repeated summation, where at any x the sub area is from x to x plus 1 by 10, and then gx dx. Now what is gx? We can start with, consider we start with x only. Anything, it is approximation, it will come down to the same location. Let's start. If I say fx equal to gx dx, then gx equal to dfx by dx. Then gx will be dfx by dx, where fx is x, it will be 1. We will start with the 1. If I start with the 1, then it will be 1 dx, it will be x, it will be x. Then x from x to x plus 10, it will be 1 by 10. It will be 1 by 10. Here this side x is there, and here this side 1 by 10 is coming, which should be x. Now I have to multiply by 10 into x to come to the level. Next approximation. Now it is 10 into x. Makes sense? Let's try again. 10 into x, where x is integration, that will be 10 into x square by 2. That is 10 by 2, and then x square. And then from x to x plus 1 by 10. Okay, then it will become x square plus 1 by 100 plus 2 into 10, 20, 20, we are trying now x square, that is the integration that came from x equal to x plus 1 by 10, that a sub area. X square, if I keep x plus 1 by 10, it will become x square plus 1 by 100, 1 by 10 whole square, 1 by 100 plus 2 into 1 by 10 into x minus x square. X square will go away. Anyway, outside 10 by 2 is waiting. And now we have 1 by 100. 1 by 100 into 10 by 2 will come as 1 by 20. 1 by 100 into 10 by 2 will become 1 by 20. And then we have 10 by 2 into x. They will take it away and it will become x. Okay, requirement is x, and we got x plus 1 by 20. So I have to subtract 1 by 20. Makes sense? If I subtract 1 by 20, right now we have taken 10 into x. Now we will do 10 into x minus, okay, I have to how much it came? It came as 1 by 20. 1 by 20. So it will be like, now x we will settle it down again. X we will settle it down again. We will make 10, and in bracket x minus 1 by 2. Something like that. If I break it, it becomes 10x minus, okay, it is not what we are thinking. Okay, we are thinking how much the difference is there. Keep adjusting step by step. That is the concept. Keep adjusting step by step. Anyway, how much it is coming? So it is coming as I believe 10 by 2 into 1 by 100. This is what I think. How much? What? How much we had taken? We'll try again. Too much confusion. We'll try again. We started with 1 dx, and it came as x. X is x to x plus 1 by 10. It became 1 by 10. Whereas expectation is it should be x. Where? So we have to multiply by 10 into x. We have to multiply by 10 into x. So it will be 10x, not 10x by 10 we are thinking. It is 10x. Now 10x integration is, right, 10x integration is x, 10 into x square by 2. 10 by 2 will come out, now I have x square. First, bottom limit is x and top limit is x plus 1 by 10. We are right now. Now x plus 1 whole square, it will become x, 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 I'm sorry, x square. 1 will become x plus 1 by 10 whole square minus x square. If someone settle it down, it will become 1 by 100. 1 by 100 plus plus 2 by 10 into x. 1 by 100 plus 2 by 10 into x. This is what it will come. X square will go away. If I multiply with the 10, okay, first is 1 by 100 and another is 2 by 10. If I multiply, it will come as 1 by 20 plus x. Expectation is x, we getting x plus 1 by 20. So 1 by 20 we have to settle down somehow. How we can settle down 1 by 20? Earlier we had taken 10x. We had taken 10x and 10x final it resulted in x plus 1 by 20, whereas 1 by 20 should not have been there. Okay, to make it kind of more clear, now we will make 10x minus, we'll try with 10x minus 1, 10 10x 10x hope 1 by 20. We'll try again. We'll try with, actually we have already tried, so I'm remembering something and I'm trying to mix it. Let's try with 10x minus 1 by 2. 10x minus 1 by 2. How we will go successive? Actually, it should come as 10 and in bracket x minus 1 by 20. Hope I like we are reaching. Okay, 1 by 20 we were getting extra. So now instead of x we will say x minus 1 by 2. Outside we have 10. It will become 10 and in bracket x minus 1 by 2. Hope x minus will x minus 1 by 20. I think so. 10 and in bracket x minus 1 by 20. Yeah, it is right. I have to subtract 1 by 20 to come to level now. 10 and in bracket x minus 1 by 2. X minus 1 by 20. If I break it, it becomes 10x minus 1 by 2. 10x minus 1 by 2. This is all right now. If I do 10x minus 1 by 2, and then if I do integration again, then 10x square by 2 minus 1 by 2x. Okay, 10x square by 2, it will become again as 1 by 20. 1 by 20 plus x. See, minus 1 by 2x minus 1 by 2 and x will become 1 by 10. X plus 1 by 2. So it will be minus 1 by 20. 1 plus 1 by 20 plus x minus 1. It will become x only. Perfectly all right. So the solution is that if I want to calculate 1 by 10 plus 2 by 10 plus 3 by 10 plus 4 by 10 like that, then I have a gx function called 10x minus 1 by 2. 10 is how many times we divided. So it will become nx minus 1 by 2. If I have a function nx minus 1 by 2, and if I integrate over 0 to 1, it will give the solution 1 plus 10. Now, initial what we were trying, we were chopping 0 to 10 into 20 part, 30 part. People can adjust like this only. Function will always be x. Makes sense? Now, let's go back to the original where we were in too much confusion. Okay, what was the confusion? Consider we have 0 to 10. 0 to 10, I chop it into 20 times now. Now, at the 1 we start. Okay, what we are trying to add now? We are trying to add 1 plus 1.5 plus 2 plus 2.5 plus 3 plus 3.5 plus 9.5 plus 10. This is the question written in examination. Can you add 1 plus 1.5 plus 2 plus 2.5 plus 9.5 plus 10? Can you add? Now anyone will see there are 20 terms. 20 terms. 20 terms means if I take 0 to 10, if I take 0 to 10 and if I chop it into 20 parts, it will come exactly like at 1, 1.5, 2, 2.5 like that. Then I have a function called x. Make sense? If x is 1, then height is 1. When x is 1.5, height is 1.5. Means we are trying to add all the verticals now. Okay, now what is the scenario now? We have summation fx, where fx is x where x will vary from 1, 1.5, 2. This is what the successive we are taking. But it is x only. The function is x only. Fx should equal to gx dx. Dx dx. If I take any x, then height is x only. Same as if I take gx, then if I try to calculate the sub area, then it will go from x to x plus zero point 0.5. Makes sense? Limit is changing. Earlier limit was x to x plus 1 by 10. Makes sense? Now limit is x to x plus 1 by 2. In this sub area, if this is gx, then this sub area of gx should be exactly same as what height we have. So fx equal to gx dx from x to x plus zero point 0.5, where fx and x is x only. Now someone can try. X equal to fx dx, x is from x to x plus 1 by 2. Okay, what is fx? What is gx? Now consider gx as 1. Fx equal to gx dx, dx equal to dfx by dx. Dx is 1. If it is 1, 1 dx is x. X to x plus 0 0.5 will come as 0 0.5 will come as 0.5. This side we have 1 by 2 and this side we have x. So we have to multiply by 2x now. Okay, so it will become 2x dx. That is 2x square. That will become 2x square by 2. 2 will go away, only x square will remain. Limit is x to x plus 1 by 2. So first will become x square plus 1 by 4 plus x, 2 into 1 by 2 plus x minus x square. Okay, x plus 1 by 4 will remain. Both are same. Both are same. Only matter is 1 by 4. This side x plus 1 by 4. Both are same. Only 1 by 4 is extra. We will subtract now. We will subtract now. Now what we had thought earlier, it was 2x. Now it will be 2 in bracket x minus 1 by 4, because 1 by 4 I have to subtract now. It came extra. So 2x into 1 by 4, it will become 2x minus 1 by 2. We'll try again. 2x minus 1 by 2. 2x will become x square minus 1 by 2x. Makes sense? Minus 1 by 2x. X square will settle down as 1 plus 4 plus x, the way we saw. X to x plus 1 by 2. X square will settle down and x will settle down as 1 by 4 plus x. Okay, and here it will, I have minus 1 by 2. X will be settled down as 1 by 2. Minus 1 by 4, and this side 1 by 4 plus x minus 4. Only x will remain. This is solution now. We have gx dx. Gx is 2x minus 1 by 2. If I integrate it from x equal to 0, x equal to 0 to 10 or 1 to 10, because again we are doing approximation only, we should get the result. Makes sense? 0, x is 0 to 10. X is, because limit is 0 to 10. 0 to 10, gx is 2x minus 1 by 2 dx. If someone does it, he will get 1 plus 1 and half plus 2 plus 2 and half plus 10 up to 10. If there is some variation in there, someone can adjust it again and then he will come to exact gx solution. Is it not the something that is rewarding? This, you find the integral gx formula, now you can add any series. Okay, let's try with the x square. Who is stopping us? Let's try with the x square. I have formula called x square. Formula is x square. What is x square? I want 1 by 10 whole square plus 1 by 20 whole square plus 1 by 30 whole square plus 10 by 10 whole square. This is written in examination. 1 by 10 whole square plus 2 by 10 whole square plus 3 by 10 full whole square plus 10 by 10 whole square. Someone has to calculate this formula. Okay, now someone will think about it. Looks like this is x-axis from 0 to 1 and he has chopped 10 times. And each chopping point is 1 by 10, 2 by 10, 3 by 10, 4 by 10. And he has drawn a graph whose equation is x square. Means if x is 1 by 10, then height will be 1 by 10 whole square, because equation is x square. If it is 3 by 10, then height is 3 by 10 whole square because equation is x square. Now he is writing summation fx, where summation will go 10 times. Fx will be added 10 times. Fx equal to gx dx, where x is 0 to 1. He has to find gx. If gx is found, then he can add it. Who will add? Not possible. 1 by 10 whole square plus 1 by 20 whole square plus 1 by 30 whole square. I'm sorry. 1 by 10 whole square plus 2 by 10 whole square plus 3 by 10 whole square plus 4 by 10 whole square. It is very difficult. A clever person may do like 1 by 100 plus bracket 1 square plus 2 square plus still it is very difficult. Okay, now someone can write is let take any point x, let take any point x, then what is the height here? X square, because equation is x square. So I can say at any point x, what is the height? That is fx, that is x square. Fx equal to gx dx, where area is of x strip. So area is x is from x to x plus 1 by 10. That is the strip because we have chopped it into 10 parts. Each part has a width of 1 by 10. If this is x, the next will be x plus 10. This is the sub area for gx, that gx is not x square, something else. So x square equal to integration limit in x to x plus 1 by 10 f gx dx. If I go with the start fx equal to gx dx, then gx will be dfx by dx. D, dfx dx square by dx 2x. So we will start with the 2x. 2x square by 2. 2 to gone x square. X square, if I settle it down from x to x plus 1 by 10, then it will come to the same thing. Okay, it will come as 1 by 100 plus 2 by 10 into x. Makes sense. 1 by 100 x square by, okay, we started with 2x. Integration of 2x is x square. X is x to x plus 10. Then it will become x plus 10 whole square minus x square. It will become x square plus 1 by 100 plus 2 into 1 by 10 into x minus x square. Minus x square. It will come in x and some constant, but that is not what we want. We want x square, but it came in x. Let's start with the x only, x square only. So we'll try x square dx. X square dx will become x to the power 3 by 3. Now place x and x plus 1 by 10. X to the power 3 by 3. How x to the power 3 with x plus 1 by 10 to the power 3 minus x cube by 3. This is what it will come. X plus 1 by 10 to the power 3, how much it will be? X to the power 3. X to the power 3 plus 3x square into 1 by 10 plus 3x into 1 by 10 whole square plus 1 by 10 to the power 3. Okay, minus x to the power 3. First will go away, now whole by 3. Okay, if I do by 3, then first 2, 3 will go away. It will become x square into 1 by 10 plus x into 1 by 10 whole square plus 1 by 10 to the power 3 by 3. This is what will remain. What is this side? This side is x square. All right. All right. X here it is x square into 1 by 10. Here it is x square. Looks like I have to multiply it by 10. Then only this side x square, this is x square by 10. Means I have to multiply it by 10. Now someone can start again. 10 into x to the power 3. 10 into x to the power 3. Let's start again. 10x to the power 3. I'm sorry, 10 into x square. Earlier we had taken x square. Now I have to take 10 into x square. If I do so, then it will become 10. I can keep outside. It is x to the power 3 by 3. Okay. If I do so, x to the power 3 by 3, 10 is outside. If I break it, it will come to the same situation. What is the same situation? It is x square into x plus x into x, it is x square. Okay, it is x square into 1 by 10 plus x into 1 by 10 whole square plus 1 by 10 to the power 3 by 3. You see, it will come. Now if I multiply by 10, it First term will come x square. Next term will come as x by 10. Next term will come as 1 by 10 whole square by 3. So x square is matching. Extra what we are getting here is x by 10. X by 10 plus 1 by 10 whole square divided by 3. This 1 by 3 into 1 by 10 whole square. This is extra we are getting. Now we will subtract them. Earlier we had taken 10 into x square. 10 into x square. 10 into x square minus 10 into x square minus. And then whatever we are seeing, we have to subtract it. Okay, what extra we are getting? Extra we are getting here is x by 10. So we will subtract there minus x by 10. Then extra we are getting is 1 by 3 into 1 by 10 whole square minus 1 by 3 into 1 by 10 whole square. Then someone has to continue. Okay, I'll try it. Okay, now someone has to continue and then try to do integration again and limit is x to x plus 1 by 10. X to x. Okay, how it can be simple? Simple can be, no, don't divide into 10 part, rather than take x is 0 to 10, then each width is 1, then it will be x to x plus 1, it will be simple. Okay, x to x plus 1, then it will be simple. Someone can keep on proceeding here until he will come to a gx, there gx dx from x to x plus 1 by 10. Or if I take 1 successive, then x to x plus 1, half successive, then x to x plus zero point 0.5. Both will become exactly same. That gx will come into the picture, into the calculation. And then everyone has its own will now. What you want? I want 1 plus 10 plus 2, 1 by 10 plus 2 by 10. Anyone? No, no, I don't want that. What you want? I want 1 by 100 whole square plus 2 by 100 whole square plus 3 by 100 whole square, like that up to 50 by 100 whole square. Then someone will think that looks like one he has divided one to some section into some part where equation is x square. Okay, and then he will progress between what is the width of 2 and then limit and dx, and he has to find gx, and then he can calculate the summation. This is mind-blowing research. Okay, I'll proceed in that and we'll try. Then we will proceed in e to the power. I want to be very deft in this calculation. If it is calculation is done, finding gx, then we can crack anything. Amazing, mind-blowing, head-hitting in the wall. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number.